Previously, I was calling the charge the oxidation number. This is also called the oxidation state. This is a number assigned to an atom to represent the number of electrons that is gained or lost in forming chemical bonds to another atom. Here are some basic rules to get you started in assigning oxidation numbers. Rule number 1, elements. Oxidation number 0 is not bonded to another atom and it neither loses or gains electrons. Number 2, monoatomic ions. The oxidation number is the charge of the ion. So for example, the iodide ion, I minus, is -1. Magnesium 2 plus is +2. Number 3, metals in molecules. Metals of group 1, column 1 in the periodic table, is always +1. Lithium, sodium, potassium, rubidium, cesium are +1 metals. Metals of group 2 is always +2. Beryllium, magnesium, calcium, strontium, barium. This is column 2 in the periodic table. Metals of group 13, this is aluminum, is always +3. So here are some examples. Sodium chloride, NaCl, sodium is +1, the chloride is -1. AlN is aluminum nitride, and aluminum is +3, the nitrogen is -3. The rules for assigning the oxidation number continues on this page. Number 3, metals in molecules. The rest of the metals in the periodic table will depend on the oxidation state of the nonmetals. Number 4, the nonmetals in molecules. Group 17, fluorine is always -1. Chlorine, bromine, iodine are normally -1 except when bonded to oxygen. Group 16, oxygen is -2 normally. When bonded to group 1 or group 2, it can be -2 or -1, and this will depend on the stoichiometry. Number 5, hydrogen in molecules. Hydrogen is +1 with nonmetals and -1 with metals. Number 6, the sum of the oxidation number of all the atoms in a neutral compound is 0. Number 7, the sum of oxidation numbers of all the atoms in a polyatomic ion equals the charge of the ion. Let's look at examples of assigning oxidation states or oxidation numbers. Recall, in ionic compounds, there is a charge balance between ions. So for example, LiF, lithium is +1, fluorine is -1. There is only one balanced formula, this is lithium fluoride. BaCl2, Ba is +2 and Cl is -1. Two chlorides with a -1 oxidation number needs to balance the barium 2+ ion. There's only one formula, this is barium chloride. Ca3N2, calcium is +2, it comes from column 2, and nitrogen is -3. There is a net transfer of 6 electrons. This ionic compound is called calcium nitride. So note, within these ionic compounds, the metal loses electrons, oxidation occurs, and the nonmetals gain electrons, reduction occurs. To assign the oxidation number or oxidation state of the rest of the metals that are not in group 1, group 2, or aluminum, the oxidation state of these metals will depend on the oxidation state of the nonmetals. So for example, here are some neutral ionic compounds. FeCl2, the chloride is -1, the iron is unknown. A simple formula can be used to help determine the charge of the unknown. The sum of the unknown oxidation state plus the sum of the known oxidation state is equal to 0. Letting X serve as the oxidation of iron, then X plus 2, there are 2 chlorides, times -1 is the oxidation state of the chloride, is equal to 0. So X is equal to +2. Another example is FeCl3. X plus 3 times -1 is equal to 0. X is equal to +3. Here's another example, SnO2. The oxidation number of oxygen is -2, so X plus 2 times -2 is equal to 0. X is equal to +4 for the oxidation state of tin. Here are more complex examples. For example, complex ionic compounds like KMnO4. Potassium is +1 oxidation state. Manganese is unknown, but oxygen is equal to -2. So using the sum of the oxidation state of known plus the sum of oxidation state of unknown is equal to 0. We know potassium and oxygen is +1 and -2 respectively. So there is a total of -7 for the oxidation state of the known elements. For manganese, there's only manganese. So -7 plus X is equal to 0, and X is +7. Here is another example of Na2Cr2O7. This is called sodium dichromate. Sodium is a +1 oxidation state, oxygen is -2 oxidation state, and chromium is unknown. So known oxidation state, there are 2 sodiums times +1, and oxygen, there are 7 oxygens -2 for a total of -12. There are 2 chromiums. We'll serve this as 2 times X. And so -12 plus 2x is equal to 0, x is equal to +6.